Welcome to Brain Vision.
For this question, we have a person basically being compressed onto a spring until the spring actually is compressed by 0.53 meters. Now we want to find what is the speed, right, at which the person is traveling just before it hits the ceiling, and the distance from the person to the ceiling is actually 0.9 meters. So let me draw that diagram for you. We have a person over here, and the ceiling is at a distance of 0.9 meters. What you will first need to do is to find what is the spring constant. In order to find what is the elastic potential energy that was stored, and we can equate the elastic potential energy to the gravitational potential energy at this particular point plus the kinetic energy, and from the kinetic energy we can get our velocity of this person. So first off, we know that the person with mass m will compress the spring by 0.18 meters. So basically mg is equals to k times 0.18 meters. Alright, so k is basically mg divided by 0.18. This is going to be very important for later. So now the kinetic energy you can find by taking the total elastic potential energy minus away the gravitational potential energy that is gained right during this flight. Elastic potential energy is half kx square, where x is given to be 0.53 meters, and this is the compression squared, minus mgh would be mg times 0.9 meters. Substituting the value of k, which is mg divided by 0.18 square minus mg 0.9. Now remember, kinetic energy is half mv square, so we can cancel out all of the m, right? So the m all will be cancelled out because there's m on both sides. So the expression simplified is minus g times 0.9 is equals to half v square. And so with this, we know that g is 9.81. We just substitute in, we can get v to be 3.1 meters per second. Now we want to assume that there's no ceiling. In this case, we want to find what is the height that he will be able to reach. So basically, at that point in time, the total kinetic energy must be zero, right? It wouldn't be moving, and so the elastic potential energy is completely converted to gravitational potential energy. So basically EPE must be equals to gravitational potential energy, implies that half kx squared equals h, where h is unknown in this case, which is equals to half kx squared divided by mg. Same thing, we substitute in what is k, which is mg over 0.18. X square is 0.53 square. Divide this by mg, so the mg will cancel out, and what we're left with is just half times 0.53 square divided by 0.18, which would leave us with 1.4 meters. Lastly, assuming that if we were to do it in a different planet with a different value of g, we want to see if this actually affects our stunt. And from our expression for our h, right, over here we see that it doesn't depend on g, right? It just depends on the extension, the compression of the spring, as well as the initial compression when there's no external force. So it doesn't depend on g, and so the h, the height that you will get, is the same value.